students, good morning. Myself Murali Krishna Reddy, senior chemistry lecturer in Trinity Junior Colleges. In last class, I completed oxides. Then we discussed about group 15 elements. In group 15 elements, hydrates, oxides completed. In yesterday's, in last class, oxides completed. Then today discussed about halides, then properties, and then dinitrogen, nitrogen and its compounds. So that halides means reactivity towards halogen. Halides. All these elements reacts with halogens to form two types of oxides: trihalides, pentahalides. All these elements means group 15 elements. All these elements forms two types of halides. Two types of halides except nitrogen. Then first one, trihalides. Second one, then pentahalides. Pentahalides. All these elements except nitrogen almost forms two types of halides. First one, trihalides. All these elements directly reacts with the halogen to form trihalides of formula MX3. M means group 15 element. First point, all these elements means group 15 elements. All these elements directly reacts with halogens. Directly reacts with halogens to form trihalides. Trihalides of formula MX3. Of formula MX3. All these trihalides are covalent. Next point. All these trihalides are covalent except BiF3. Except BiF3. It is which is ionic. BiF3 is ionic. Except this one, remaining all trihalides are covalent. Then next point. All these trihalides are stable. All these trihalides are stable except NCl3, NBr3 and Ni3, which are unstable. Which are unstable. NCl3, NBr3. All these trihalides are stable except NCl3, NBr3 and Ni3, which are unstable due to reason low polarity of NX bond and large difference in the size. Large difference in the size of nitrogen atom and halogen atoms. Here remember that all these trihalides are NCl3 means stable except except NCl3, NBr3 and Ni3, which are unstable due to means NCl3, NBr3, Ni3 are unstable due to low polarity of NX bond and a large difference in the size of nitrogen atom and halogen atoms. Large difference means nitrogen is very small atom, then nitrogen fluorine NF bond is a strong bond formed because nitrogen fluorine size almost same, but NCl size increases to chlorine, effective overlapping decreases, here 2p orbital, here 2p orbital overlapping, but in this case here 3p orbital. So then in this way NBr, Ni, then size of halogen atom increases, then stability decreases. So that's why NCl3, NBr3 and NIR3 are unstable. Only these three are unstable due to low polarity of NX bond and large difference in the size of nitrogen atom and halogen atoms. Then all these trihalides are sp3 hybridized, sp3 hybridized of central atom and pyramidal shape, having pyramidal shape or trigonal pyramidal shape. Then in this way here, suppose NCl3 or PCl3 example, then here PCl3, chlorine, then having lone pair of electron, sp3 hybridization and then pyramidal shape. And all these trihalides, see that here lone pair present on central atom, a lone pair LP present on central atom, a lone pair present on central atom. Due to presence of lone pair of electron, remember here, due to presence of lone pair of electrons, they act as Lewis bases. They act as Lewis bases. The tendency to act as Lewis bases, then decreases from Ni3. In case of nitrogen, presence of lone pair acts as Lewis basis. The tendency to act as Lewis basis in case of nitrogen halides. In case of nitrogen halides or halides of nitrogen. In case of halides of nitrogen decreases from Ni3 to NF3, means order of Lewis basic strength, among nitrogen halides, Ni3 greater than, NBr3 greater than, NCl3 greater than NF3 due to reason. See that a lone pair present on central atom, due to presence of lone pair of electron, they act as Lewis bases. The tendency to act as Lewis bases in case of halides of nitrogen decreases from Ni3 to NF3. Why Lewis basic strength decreases from Ni3 to NF3? See that the strength of Lewis base depends on the electron density on central atom. Here all these halides central atom having lone pair, but here iodine low electronegativity, fluorine central atom same, nitrogen, only bonded atom changes. Whenever bonded atom changes, electronegativity changes. Which has more electronegativity? Fluorine has more electronegativity. Due to more electronegativity, fluorine withdraws electrons towards itself. At that time, nitrogen electron density decreases. But fluorine to iodine electronegativity decreases. Here iodine low electronegativity, it do not withdraws electrons means strongly, hence electron density more on nitrogen. Therefore, in case of hydrates, we explained on moving down the group means NH3 to BiH3, Lewis basic strength decreases. At that time, nitrogen, phosphorus, arsenic, antimony, size of central atom increases, lone pair spread over the large size, that is central atom changes. But here central atom similar, nitrogen, 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 nitrogen. Bonded atom changes. At that time, bonded atom electronegativity increases, then Lewis basic strength decreases. Because electronegativity increases means observing that in case of NF3, fluorine, then fluorine high electronegativity, they withdraws electrons towards itself. At that time, electron density on nitrogen decreases. Hence, Lewis basic strength very less for NF3. Reason here, due to increase in electronegativity. Due to increase in electronegativity from iodine to fluorine. So see that here all these trihalides, all these elements forms two types of halides, trihalides, pentahalides. So except nitrogen, nitrogen do not form pentahalides. All these elements except nitrogen here, except nitrogen only forms trihalides. All these elements directly reacts with halogens to form trihalides of formula MX3. All these trihalides are covalent except BAF3. All these trihalides are stable except NCl3, NBr3, Ni3. Among nitrogen halides, only NF3 is stable. Remaining NCl3, NBr3, Ni3 are unstable. That is reason, means which are unstable due to low polarity of NX bond and a large difference in the size of nitrogen atom and halogen atom. Nitrogen small size, so chlorine, fluorine, nitrogen, fluorine almost similar size, but chlorine, bromine, iodine size increases, effective overlapping decreases, hence stability decreases, exist but unstable. And all these trihalides are sp3 hybridizer of central atom and a pyramidal shape, example PCl3. A lone pair present on central atom. Due to presence of lone pair of electron, all these trihalides means they act as Lewis bases. The tendency to act as Lewis bases in case of halides of nitrogen means trihalides of nitrogen, then decreases from Ni3 to NF3. Order of Lewis basic strength Ni3 to Ni3 greater than NBr3 greater than NCl3 greater than NF3 due to increase in electronegativity from iodine to fluorine. When electronegativity of bonded atom increases, then Lewis basic strength decreases, because bonded atom more electronegativity means withdraws electron from central atom. At that time, electron density decreases. Always remember that Lewis basic strength depends on the electron density on central atom. More electron density, more donating capacity and more basic strength. Less electron density and less electron density means less donation capacity, less basic strength. Here in case of nitrogen trihalides, then nitrogen is central atom similar, no change in size, only bonded atom changes. Hence bonded atom electronegativity increases, then Lewis basic strength decreases, because electronegativity more for bonded atom withdraws electron from central atom, decreases electron density. Hence NF3 is weak base, this Ni3 is strong base. And another, in case of only halides of nitrogen, then in case of halides of group 15 elements, then what is the basic strength? Means so NX3 means PX3. In that way, what is the Lewis basic strength? Basic strength of nitrogen halides completed. Then basic strength of halides of group 15 elements. In case of halides of group 15, for example, then NCl3, PCl3, ASCl3, then SbCl3, then BiCl3 is there. At that time here bonded atom similar, halogen similar, but central atom changes, nitrogen, phosphorus, arsenic, antimony and bismuth. Then here apply the concept of hydrates. In case of hydrates, then on moving down the group, lone pair spread over the large size atom. Hence, electron pair density decreases, basic strength decreases. Similarly, in case of trihalides, means trihalides of group 15 elements, the Lewis acidic strength, basic strength decreases from nitrogen to bismuth, then because increase in size. So here also Lewis, here conclusion also the tendency to act as Lewis base decreases from nitrogen to bismuth, nitrogen halide to bismuth, means NCl3 more basic, here order of basic strength. Here what is the reason? Already explained in group, means hydrates. Here central atom different. In case of nitrogen trihalides, bonded atom different. Here central atom size increases, so the tendency to act as Lewis basic strength decreases from nitrogen to bismuth for a given halide. Remember, for a given halide. For a given halide means either NF3, PF3, ASF3, or NCl3, PCl3, PCl3, SbCl3, or NBr3, PBr3, ASBr3, SBr3. In that given, for given halide, Lewis basic strength decreases from nitrogen to bismuth, because in these cases central atom size increases, lone pair spread over the large size, hence lone pair electron density decreases, hence Lewis basic strength decreases. And one more point, remember that here the trihalides of phosphorus and arsenic, the trihalides of phosphorus and arsenic, especially fluorides and chlorides also acts as Lewis acids, means accepting lone pair of electrons, also acts as Lewis acids due to presence of vacant d orbitals. Due to presence of vacant d orbitals. So that are trihalides. Next, hydrolysis of trihalides. Important topic. Hydrolysis means reaction with water. Hydrolysis of trihalides. Except, first point, except NF3, comma PF3, all trihalides of these elements, all trihalides are hydrolyzed by water. All trihalides are hydrolyzed by water except NF3, BF3. They do not undergo hydrolysis. All trihalides are hydrolyzed by water. Then NCl3 plus 3H2O then gives rise to here formation of NH3 plus 3HOCl. It is the hypochlorous acid, oxy acid formed. Due to formation of hypochlorous acid, aqueous solution of NCl3 acts as a bleaching agent, means colored substance is converted into colorless substance, because whenever NCl3 dissolved in H2O reacts with H2O, what will be formed? NH3 and HOCl. HOCl unstable, further decomposed to form HCl and nascent oxygen. That nascent oxygen converts colored matter into colorless matter. Then a PCl3 hydrolysis means reaction with water, then it gives rise to phosphoric acid H3PO3 plus phosphorus acid, not phosphoric, phosphorus acid H3PO3, phosphorus acid. Then PCl3 is a covalent compound, but its aqueous solution is a good conductor of electricity due to formation of HCl. Because PCl3 reacts with H2O, then PCl3 is a covalent compound. PCl3 is a covalent compound, but its aqueous solution, of PCl3, aqueous solution of PCl3 is a good conductor due to formation of HCl, H plus Cl minus. Similarly, arsenic trichloride plus 3H2O forms arsenious acid H3ASO3 plus 3HCl. SbCl3 plus H2O then gives rise to SbOCl, then gives rise to plus 2HCl reversible. BiCl3 hydrolysis of bismuth chloride H2O then gives rise to BiOCl plus 2HCl is formed. See that here the extent of hydrolysis decreases from nitrogen halide to bismuth halide. The extent of hydrolysis decreases. Extent of hydrolysis decreases from NX3 to BiX3. Then order of hydrolysis, for example, order of hydrolysis, NCl3 in case of chlorides, NCl3 greater than, PCl3 greater than, ACl3 ready to undergo hydrolysis, then SbCl3, then BiCl3. Here observing that NCl3 hydrolyzed to base, it is a NH3, it is base, and PCl3 hydrolyzed to acid. NCl3 hydrolyzed to base, PCl3 hydrolyzed to acid. So remaining ACl3 also hydrolyzed to acid, and here SbCl3 forms oxochloride, here also oxochloride. SbCl3, BaCl3 forms oxochlorides, or phosphorus arsenic forms acids, phosphorus acid, arsenious acid. Then NCl3 forms NH3 and HOCl formed. So why NCl3 is hydrolyzed to base, PCl3 is hydrolyzed to phosphorus acid? Here reason see that NCl3 is hydrolyzed to ammonia base. Hydrolyzed to ammonia means base, while PCl3 is hydrolyzed to acid, that is H3PO3. It is due to fact that NCl3 acts as a electron pair donor, while PCl3 acts as a electron pair acceptor due to presence of d orbital, vacant d orbital in phosphorus. Here NCl3 acts as electron pair donor. NCl3 hydrolyzed to base while PCl3 hydrolyzed to acid is due to fact that NCl3 acts as electron pair donor while PCl3 acts as electron pair acceptor. So that why NCl3 acts as a electron pair donor, how it is acts as a electron pair donor. So in that reaction NCl3, here nitrogen, then chlorine, then here chlorine plus H2O, then here H, then OH. Here lone pair, this lone pair transferred to here, then here elimination of HOCl, then gives rise to Cl2NH, then plus HOCl is formed. In similar way, it reacts with another 2 H2O molecules, then one H2O replaces one chlorine, then forms NH3 plus 2 HOCl. Here nitrogen acts as the electron pair donor, while PCl3, see that reaction, PCl, then chlorine, here lone pair present, but then O, then H2, then now here accepting lone pair, then HCl eliminated, that gives rise to Cl2, then POH is formed, then plus HCl. In similar way reacts with 2H2O, then forms POH taken thrice plus 2HCl. POH taken thrice means H3PO3. Here see that nitrogen acts as electron pair donor, phosphorus acts as electron pair acceptor, but nitrogen do not act as electron pair acceptor because no vacant d orbital. Already given, especially fluorides and chlorides also acts as fluorides, phosphorus means phosphorus, arsenic, chlorides also acts as Lewis acid due to presence of vacant d orbitals. So that's why here NCl3 acts as Lewis base, but here PCl3 acts as Lewis acid, hence here base formed, here acid formed. So that is about hydrolysis of trihalides. Important hydrolysis of trihalides, Lewis basic strength and as well as extent of hydrolysis. So then next discussed about pentahalides. Nitrogen cannot form pentahalides. MX5. Nitrogen cannot form pentahalides. Reason: due to absence of vacant d orbitals. Means it cannot expand its valency behind 4. Absence of vacant d orbitals. And bismuth forms unstable pentahalides. Bismuth forms unstable pentahalides due to inert pair effect. Unstable pentahalides, only BAFI is stable, remaining unstable due to reason is the inert pair effect. Due to inert pair effect, bismuth plus 3 oxidation state is more stable. Nitrogen cannot form pentahalides due to absence of vacant d orbital. Bismuth forms unstable pentahalides due to inert pair effect. All these pentahalides are covalent. All these pentahalides are covalent and sp3 dehybridized. sp3d hybridized of central atom and having trigonal pyramidal shape. Having TBP, trigonal bipyramidal shape. Trigonal bipyramidal shape. Then what about this hydrolysis? Means hydrolysis of pentahalides. Trihalides forms different NH3 forms NCl3 forms NH3 and HOCl, and PCl3 forms hydrolysis phosphorus acid, and PCl5 undergoes two-step hydrolysis. PCl5 undergoes two-step hydrolysis. Two-step hydrolysis. Then PCl5 plus H2O then forms POCl3 plus 2HCl. Further POCl3 plus 3H2O that gives rise to phosphoric acid is formed plus 3HCl. Means PCl3 forms phosphorus acid, PCl5 forms phosphoric acid. Then these pentahalides generally decomposes PCl5 into PCl3 plus Cl2. Then pentahalides, so X-ray studies confirms that according to X-ray studies, PCl, solid PCl5, it is in gas state piece trigonal pyramid. Solid PCl5 exists as ionic compound, means PCl4 plus PCl6 minus, and PBr5, solid PBr5 exists as solid PBr5 exists as PBr4 plus Br minus. According to X-ray studies, confirms that, or according to X-ray studies, solid PCl5 exists as PCl4 plus PCl6 minus ionic compound, and solid PBr5 exists as PBr4 plus Br minus. Then these pentahalides acts as a Lewis acids. Then hybridization changed from sp3d to sp3d into sp3d2. These pentahalides are acts as then Lewis acids due to presence of vacant d orbitals. Due to presence of vacant d orbitals. Therefore mx5 plus x minus then gives rise to mx6 minus formed. Then here hybridization here sp3d then will be changed to sp3d2. Trigonal bipyramidal changed to octahedral. Then pentahalides are more covalent than trihalides. Pentahalides are more covalent than trihalides. Reason why pentahalides are more covalent according to Fajan's rules. Then here in pentahalides plus 5 oxidation state, in trihalides plus 3 oxidation state. Plus 5 oxidation state means charge increases, polarizing power increases, then covalent character increases. In case of pentahalides plus 5 oxidation state, in due to here reason, because in case of pentahalides, so in case of pentahalides plus 5 oxidation state of central atom, central atom has more polarizing power. Central atom, in case of pentahalides, the central atom in plus 5 oxidation state, the central atom in plus 5 oxidation state is more polarizing power. polarizing power. Then +3 central atom of then +3 oxidation state of trihalides. +3 oxidation state central atom of trihalides. Pentahalides are more covalent than trihalides because in case of pentahalide the central atom in +5 oxidation state is more polarizing power than +3 oxidation state of central atom of trihalides. So that is about trihalides and pentahalides. Dinitrogen preparation and properties. Dinitrogen N2. First, preparation methods. Laboratory preparation methods. Laboratory preparation methods. In the laboratory, dinitrogen is prepared by the laboratory. Dinitrogen N2 is prepared by the treating of aqueous ammonium chloride means NH4Cl with sodium nitrite, not nitrate, NaNO2. Then reaction NH4Cl plus aqueous NaNO2 then gives rise to N2 plus, then forms here 2H2O plus NaCl formed. Nitrogen is formed. Then a small amount of NO and HNO3 also formed in this reaction. These impurities that are called impurities. These impurities are removed by passing through the aqueous solution of sulfuric acid containing potassium dichromate. After that, small amounts of NO and HNO3 are also formed in this reaction. These impurities are removed by passing through aqueous solution of sulfuric acid H2SO4 containing dichromate, potassium dichromate or sodium dichromate. It is the preparation. And N2 is also obtained by the dinitrogen. N2 is also obtained by the thermal decomposition of ammonium dichromate and ammonium dichromate and ammonium nitrite, not nitrate, ammonium dichromate and ammonium nitrate. Here what is ammonium dichromate formula? NH4 taken twice Cr2O7 on strong heating gives rise to N2 plus Cr2O3 plus 4H2O. Ammonium nitrate NH4NO2 NO3 nitrate NO2 nitrate gives rise to N2 plus 2H2O is formed. Ammonium dichromate or ammonium nitrite, not nitrate. and thermal decomposition gives N2. Next, N2 is also obtained by the dinitrogen. Third method, N2 is also obtained by the action of then NH3 on cupric oxide CuO or bleaching powder CaOCl2. 2NH3 plus 3CuO then gives rise to N2 plus 3Cu then plus 3H2O, or 2NH3 plus 3CaOCl2 then gives rise to N2 plus 3CaCl2 plus 3H2O is formed. Action of NH3 on cupric oxide or bleaching powder CaOCl2, nitrogen is formed. Very pure nitrogen is obtained by the very pure N2 is obtained by the thermal decomposition of sodium or barium azide. Thermal decomposition of sodium or barium azide. Remember, sodium or barium azide means heated in absence of vacuum. Sodium azide formula, azide means N3 minus Na plus N3 minus, it is called sodium azide. Just on heating in vacuum then forms 2Na plus 3N2, no impurity, and it is the sodium azide formula. And our barium azide, BaN3 taken twice, it is barium azide, either sodium azide or barium azide on strong heating, Ba plus 3N2, nitrogen is found. Very pure nitrogen is obtained. Then here in the laboratory, nitrogen obtained by treating of aqueous ammonium chloride with sodium nitrate. Small amount of NOHNO3 also formed impurities. These are removed by passing through the aqueous solution of H2SO4 containing dichromate. Also obtained by thermal decomposition of ammonium dichromate or ammonium nitrite. Then N2 is also obtained by the action of NH3 on CuO or CaOCl2. And also very pure nitrogen is obtained by the thermal decomposition of sodium or barium azide. Commercial preparation method, industrial commercial preparation of N2. Dinitrogen is prepared commercially by the liquefaction and fractional distillation of air. Dinitrogen commercially on large scale. Commercially on large scale, N2 is prepared by the then liquefaction and fractional distillation of air. Liquefaction and fractional distillation of air. Air having the almost 79 to 80% nitrogen, dinitrogen, and 21% oxygen. Whenever air on liquefaction, then that converted into liquid state, further subjected to fractional distillation. Fractional distillation means the substances are separated by the difference in their boiling points. So in the fractional distillation, nitrogen boiling point 77.2 Kelvin. Hence, first nitrogen distills out, liquid nitrogen distills out, leaving behind liquid, then O2. First nitrogen, liquid nitrogen distilled first out. On fractional distillation, liquid N2 is distilled out first. Leaving behind liquid O2, because O2 leaving behind liquid O2, because N2 boiling point 77, O2 boiling point 90 Kelvin, hence first liquid N2 is distilled out. So that are the preparation methods of dinitrogen completed. Then in next class we are discussing about properties of dinitrogen, applications of dinitrogen, and then nitrogen compounds NH3 and HNO3. Thank you.